What is inheritance? Creating a new class from existing class. Uh, in inheritance, existed class is said to be superclass. New class is said to be subclass. Whenever superclass object is created, then memory allocated to superclass members only. Subclass object is created, both superclass and subclass. See, yesterday one program you have seen, class A, integer x equal to 10, void show system dot out dot println A class. Class B extends A, int y equal to 20. What is the method name I given yesterday? Print. Void print. System dot out dot println B class. Okay. Now A class inherited in B class. B class derived from A class. Now here A OB1 equal to new A. System dot out dot println OB1 dot X. OB1 dot show. System dot out dot println OB1 dot Y. OB1 dot print. Like this you can create. Now here A object created, A reference created. Now if you write like this, what will happen? See, you can access only A members. A OB1 equal to new A. If you write like this, memory allocated to X as well as show. It's an A object. This object referred by OB1. Now here system dot out dot println OB1 dot X. System dot out dot println OB1 dot Y. OB1 dot show. OB1 dot print. In these 5 lines, first line, it is valid. Okay. Now, in these 4 lines, which are valid, which are not valid? First one, valid. Second one, not valid. Third one, valid. Fourth one, first you write this one. Only A members you can access. B members error. In this line, which class object created? A class. Which class reference created? A class. A is a superclass or subclass? Superclass. So memory allocated to only superclass members. Okay. This is one combination. See one more. You observe second one. BOB2 equal to new B. Which class object created? B is superclass or subclass? Then memory allocated to both superclass and subclass. It is B object. This object referred by OB2. Here, this is inner circle A members. Now, system.out.println OB2.x, system.out.println OB2.y, OB2.show, OB2.print. Now, this first line, B object created, B reference created, valid. These are, which are valid, which are not valid? All are valid. All you can access. Write this one also. So all members you can access. A class members and B class members. All we can access. B object created. Memory allocated to A class members and B class members. So we can access A members and B members, all. So yesterday, whatever you have seen that example, for that example only 4 combinations possible. This is one, this is one. 2 more I'll give. Here, A class object created, A class reference created. Here, B class object created, B class reference created. Is it completed? Here, B is superclass or subclass? Then memory allocated to both superclass and subclass. That's what A members, B members, all we can access. A members and B members, all we can access. Is it completed? See, third one. Third one you observe. AOB3 equal to new B. Here, which class object created? A class or B class? B class. Object is right side or left side? So object is created right side. So which object created? B class object created. Memory allocated to both A class and B class. Okay. In this B object, A members are present or not present? That is the reason it is valid. That is the reason it is valid. See what will happen. Just you observe. X show, Y print. Here B object, A reference. These all A members. Now reference is created to A class or B class. That's what only this circle it can access. So memory allocated for both A class and B class, but you cannot access B members. This is if you create like this. System.out.println ob3.x. System.out.println ob3.y. ob3.show. ob3.print. First one, valid or not valid? Second one, not valid. Third one, valid. Fourth one, not valid. Now write this one. It is A reference. It will refer only a memory. That arrow you observe. Which class object created? A or B? B class. Which class reference? That's what it refers only a memory. It refers object, but in that object, it will points to a memory only. Now, one more. Fourth one. BOB4 equal to new A. Which class object created? A class. A class is superclass or subclass? Superclass. Memory allocated to? Only superclass. Only superclass. Reference created to which class? B class. Is there any B memory? That's what. This is not valid. This is not valid. That is only not valid means accessing is not valid. Okay. First line only error. Remaining all system.out.println also you cannot write. Okay. In that A object, B members are not present. That's what not valid. But in that B object, A members are present. That's what valid. Got it? In B object, A members are there. Valid. In A object, B members are not there. That's what not valid. Alright, this one. In A object, B members are not present. That's what not valid. But in previous one, B object, in that A members are present. That's what valid. Now, you studied 4 combination. Listen, what you are doing. You 2 members. Now, you studied 4 combinations. Okay, 4 combination. Which one is better? 1, 2, 3, 4. Which one better? Second one is better. Memory allocated to all, you can access all. Memory allocated to all members, you can access all members. So, second one is better. Now, suppose if you write first one, see 4 combinations you have seen. AOB1 equal to new A. Next, BOB2 equal to new B. AOB3 equal to new B. Next, BOB4 equal to new A. 4 combinations. In 4 combinations, first one we should not use. If you write first one, writing B class is wasted. Got your point? AOB1 equal to new A, if you write, writing B class is wasted. Then B class memory wasted, B class is wasted, writing is wasted, everything wasted. If you use fourth one, it is anyhow error coming. It is not possible. Now, first one we should not use. If you use first one, writing B class is waste. Fourth one, anyhow not possible. Present not possible, later we'll see that one. That is in polymorphism, I'll explain again. Okay. Now, first one we should not use. Fourth one, not valid. Second and third, which is better? Present, second better. Okay. In future, one situation I'll show you. Third one also better. That's what. Present only while inheritance, while learning inheritance, it is better. Later, while after learning polymorphism, it is also better appears. Depends upon situation. Okay. Now, first one we should not use. It is valid only. Valid only. Okay. It is valid only. It is valid only. It is valid only. This is only not valid. Okay. But we should not use this one. If you use that one, writing inheritance is waste. If you use that one. Now, that's what, don't use first one. Fourth one, anyhow error coming. Second and third, present, second better. After learning polymorphism, third one also better. Situations. Depends upon situation. Sometimes second one better. Sometimes third one better. Depends upon situation. That is we have to use. Okay. Present. This is you learn. Now one more example. Here I'll remove this instance method. Now only one method is there in subclass. Okay. Now B B OB equal to new B. OB dot print. OB dot print. Which class object created? Is it superclass or subclass? Then memory located to both superclass and subclass. Which class reference created? It can access both A class members and B class members. Now, before going to this one more point I'll explain. AOB1 equal to dash. Can I write new A? In the dash, can I write new A? Can I write new B? Yes. Here, you can write new A. You can also write new B. Can we access B members? No. So, it is superclass reference or subclass reference? Superclass reference can refer superclass object and subclass object, but we can access that point. Note down. Superclass reference refers both superclass object and subclass object. Superclass reference refers both superclass object and subclass object, but it can access superclass members only. Superclass reference refers both superclass object and subclass object, but it can access superclass members only. AOB1 equal to dash. In this dash, you can write new A also, new B also. Superclass reference can refer, superclass reference refers both superclass object and subclass object, but it can access superclass members only. Now, if left side A is there, right side A also valid, B also valid. Suppose left side B is there, right side only B. That means same based on this one, that point give me answer what we are write. Subclass reference refers, subclass reference can refer, subclass reference refers only subclass object. But it can access right, both superclass and subclass members. Confusion is there, but I given clarity. Okay. Subclass reference refers only subclass object, because BOB2 equal to new B, but can access A member? That's what. But it can access both superclass and subclass members. Right, this one. BOB2 equal to dash. You can write only new A. New B. Subclass reference refers only subclass object, but it can access both superclass and subclass members. With this OB2, can I access A members? With OB1, can I access B members? No. It refers B object, but we cannot access. Got it? This is remember further required. Okay. Further required, remember. Superclass reference refers. Superclass reference refers both superclass object and subclass object, but it can access only superclass members. Subclass reference refers only subclass object, but it can access both superclass members and subclass members. Okay. The concept, remember, in further session again record, I'll ask while teaching. Okay. Now, in A class, one instance variable X, I removed show method. In B class, one instance variable Y and one print method. Now, B object I created, B reference I created. With this, can I access A members? Can I access B members? Both A and B we can access. OB.print, control comes here. Here, integer Z equal to 30. Here, system.out.println, suppose X. System.out.println Y. System.out.println Z. Now, this program, you observe, A class contains one instance variable X. B class extends A class. It is inheritance relationship. Here also one instance variable Y. Print method. It is local variable Z. Now, here demo class object I created, B object I created, with that I call print method. Control comes here. These three lines are valid or not valid. Which are valid, which are not valid. Otherwise, all are valid. What is? All are valid? Sure. Think yourself and give answer 11, line number 11, 12, 13. First two valid. Third not valid. Next. All are valid. Next. Line number 11, 12, 13. These three lines, each and every line you observe. Whatever you studied with that knowledge, think and give answer. All are valid? 12 not valid. 11, 13 valid. Okay. 13 not valid. 11, 12 valid. Okay. 3 answers came. 3 answers. 11, 12 valid. 13 not valid. One more 11, 13 valid. 12 not valid. One more all are valid. Next. Any other answer? Any other answer? Online students also give answer. Eleven error. One more answer came. 11 error. That means 12, 13 valid. Any other? All are not valid also is there? Any other answer? 4 answers came. 4 answers. Now, here, which class object created? B is superclass or subclass? Memory allocated to both superclass and subclass. X memory allocated, Y memory allocated. B object referred by B reference. With that print method called, it is B member. You can call local variable memory also allocated. All variables memory allocated. Okay. All variables memory allocated. Now, all variables memory allocated. X, Y, Z. Now, all variables memory allocated. System dot out dot println X. System dot out dot println Y. System dot out dot println Z. Now, X instance variable or class variable or local variable. How many ways to access? What are those? Y, which type of variable? Now, here, is it those who given valid? How it is valid here? This dot X. Here, this dot Y. Here, directly valid because local variable. So, all are valid. Implicitly, this dot X. Implicitly, this dot Y. Okay, all are valid. Write this one. Here, implicitly, this dot X. Here, implicitly, this dot Y. Implicitly, this dot X. Implicitly, this dot Y. See, X memory allocated 10. Y memory allocated 20. Both are in B object. Both are in B object. This object referred by OB. This object referred by OB. Here, it is A member. Z memory allocated, that is 30. Okay. It is A, it is B member, it is local variable. Now, this keyword, what it refers? Current object. That's what you can access X also, Y also. Those who given line number 11 not valid. Why it is not valid? You selected, what basis you selected? Those who selected 11 not valid. On what basis you selected it is not valid? Those who given 12 not valid. On what basis you selected 12 not valid? Object reference not there. Like that you selected. But X 11 also object reference not there, no? Only 12 you selected. Only 12 you selected, not valid. Reference is not there, that's what you selected. Okay. But reference is not there for 11 also, no? 11th one. 11 you given valid, 12 not valid you selected. On what basis you selected 11 valid, 12 not valid? Inheritance is there, that's what not valid. But Y is in the same class, no? B class only, no? Y in the same class, X is in another class. Those who given 13 not valid, what basis you selected? Local variable, no? Z is local variable. Directly we can access. Z is local variable, directly we can access. Now, you observe, here B object created, memory allocated to both A class members and B class members, X and Y. And this keyword refers complete object. This keyword refers current object. It can access X also, Y also. That's what valid. This implicitly present. Z is local variable, directly you can access. Okay. Write this diagram. B object created. A members memory allocated, B members memory allocated. That complete object data we can access with this keyword. This keyword refers current object, complete object. Z is local variable, directly we can access. That's what 30. Is it over? Now, little bit I'll change. Think yourself and give answer. Little bit I'll change. See. Little bit I'll change. This variable name is X. Here. X means what is printed. Now I written only X. What is printed? 10 or 30? What is printed? 30 printed. So it is valid, 30 printed. Y means this 20 printed, implicitly this. How to print 10? Explicitly this dot X. Then only 10 printed. Suppose this is Y. Okay. Then how to print 10? Only X. How to print 20? this dot y. How to print 30? Y. That's it. Now what I'll do, you observe. It is also x. It is also x. Only x if I write. What is the output? 30. This dot x. What is printed? 20. Here, for printing 10, one more keyword is there, super. Super dot x. Whenever superclass member and subclass member names are same, if you want to access superclass member, then super keyword required. Okay. Now, first that point node, super keyword. You already studied what is this keyword. It is called as object reference. We can also call reference variable. Why we are calling like that? Because it refers object. Which object? Current object. No. Super keyword. It is called as an object reference or reference variable because it refers superclass memory. Here, not object, only memory. It is called as an object reference or reference variable because it refers superclass memory. It is called as an object reference or reference variable because it refers superclass memory. It doesn't refer object, it refers memory only. That part only it refers. It is implicitly not present, explicitly required. It is explicitly required to access superclass member whenever both superclass member and subclass member names are same. It is explicitly required to access superclass member whenever both superclass member and subclass member names are same. Is it over? It is explicitly required to access superclass member whenever both superclass member and subclass member names are same. Here, member can be a variable or method. Note. Here, member can be a variable or method. Here, member can be a variable or method. Now, variable name same or method name same, then also you can use. Here, member can be a variable or method. Here, member can be a variable or method. Is it over? You observe. Here, demo object created, main method called b object created, memory allocated to x also, this x also, print also. OB, referred by OB dot print. Control comes here, local variable memory allocated. Only x if you write, local variable 30. This dot x if you write, 20. Super dot x if you write, 10. So 30, 20, 10. File, save. compilation, execution. See, 30, 20, 10. Write this example. Example 1. Example 1. One more I'll give. It is example 1. Now see the memory diagram. X year 10. Again X, it is 20. This is one object. P object. This object referred by OB. It refers object. This inner circle, it's an A member. Now this keyword, what it refers? Current object. That means complete. But super keyword, only superclass memory. Inner circle. Only inner circle it will refer. It refers only inner circle. Here one more X outside 30. First write this diagram. This keyword different, super keyword different. You observe. This keyword refers current object. Super keyword refers superclass memory only. That part only referred. Is it over? I'll ask some questions. Give me answer. By using this keyword, can access A members. First, what is this keyword? It is object reference or reference variable. Why we are calling like that? It refers object. Which object? Now, by using this keyword, can I access A members, B members? A members also you can access, B members also you can access. Possible. Super keyword. By using super keyword, can I access A members? Can I access B members? No. B members you cannot access. It refers only superclass memory. A memory only. You cannot access B members. That's what arrows you observe. The arrows keywords you observe. Now, this arrow only superclass memory. That arrow complete object. If variable names are different, is it super keyword required? Super keyword is not required. With this keyword only can access. Okay. If variable names are different, then super keyword is not required. Okay. But using this complete object data we can access. A data also, B data also. But using super, we can access only superclass memory. So A data only we can access. We cannot access B. Got it? It refers object. It doesn't refer object. It refers only memory, A memory, superclass memory only. Even you observe, suppose I removed .x. File, save. Compilation. What you are getting? Error. Super place you are getting error. Are you getting this place error? No. Super I'll remove. This line I'll remove. This line I'll make it as comment. Now, this. It refers current object. So hash code printed. But super doesn't refer object. It refers only superclass memory. For that hash code will not be there. What do you mean? So this if you print, you are getting hash code. But super you cannot print. It is asking dot. You observe. It is asking dot. See, dot expected. Super dot variable name or method name. You have to write. Super different, this different, not same. This keyword refers current object. Current object hash code stored in this keyword. Super doesn't refer object. It refers only superclass memory. For that separate hash code will not be there. That is the reason error coming. Now, using this keyword, can I access superclass members? Yes. Subclass members? Yes. Using super keyword, can I access superclass member? Subclass member? No. Super keyword meant for only super members, superclass members. But this keyword meant for total object. But variable name same, method name same. In that situation, this doesn't work. In that situation, use super. Okay, that is remember. Using this complete A data, B data we can access, but names are same, not accessible. In that situation only use super keyword. Otherwise, super keyword is not required. If variable names are different, method names are different, then super keyword is not required. Okay. And variable name same, method name same. If you want to access superclass members, then explicitly super keyword we have to write. Is it clear? Now, one more example. See, it is the most important topic. Don't neglect. Few students are not listening. My eyes on everyone. Listen. Listen with more concentration. While developing application, you'll face a problem. Each and every concept required while developing application. Each and every concept, if you are perfect, then application time, which concept required you have to think, you have to apply. So how many concepts are there? You observe. So many you studied till. Okay. Still so many concepts are there. All if you are familiar, then you can select right concept. Then you can develop application in a proper way. Suppose one small example, you want to buy one mobile. You want to buy one mobile. Confusion is there or not? You want to buy one mobile. How many companies mobiles are there? In each company, how many models are there? So many are there? Now, you want to buy one mobile. Lots of confusion. Which mobile have to purchase? Okay. So lots of confusion is there or not? Suppose you already decided you want to buy Samsung mobile. But in Samsung also again how many models are there? So many are there? No? So if the person is perfect in each and every feature in that mobile, suppose about RAM, he knows very well. About processor, he knows very well. About battery backup, battery power, all those things. Charger, battery, like megapixels, camera, everything. Each and everything, internal concepts also, if he knows. According to his budget, he can select right mobile. No? If the person doesn't know these all, what will happen? Only cameras they'll see, they'll buy. Later they'll realize this processor not good, battery backup not good. Later they'll realize that is happening. No, only attractive they'll see, they'll buy. Later money wasted, they'll think. If the person knows importance of RAM and processor, then he'll buy right mobile. But RAM importance they don't know, and performance they don't know. Then they are buying mobile. Later they are realizing. For this mobile, money wasted, internet is very slow, RAM is not good, processor is not good. Later they'll realize. They'll see only camera, first priority. Later they'll realize. It's happening. No? But each and every feature, high-end feature is there. Definitely that mobile 40,000 will be there. What they'll do? RAM low, camera megapixels more, and megapixels less. RAM will be more. Like that, one processor low, one low configuration, one high configuration. Like that, they'll combine. In that particular 10,000, 20,000, they'll give price. But all are high-end means definitely that will be 40,000. Like that. But actually, what purpose you are buying mobile? What purpose you are buying mobile? Which is most priority you are giving for accessing internet or selfie or camera, something. Whatever your requirement is, based on requirement, you have to choose. Based on requirement, you have to choose. That means what purpose you are buying mobile, you should know first. Which one you are giving highest priority, you should know. For that priority in that mobile, RAM required or processor required or camera required or battery required, backup required, what you have to check. Based on that, you can select right mobile. No? Like that, you are learning all internal features. That type. Present. Once if you are perfect, while developing application, you want to develop web application, internet. Then whether super required or this keyword required or overloading required, overriding required, inheritance required or polymorphism required, is a relationship, has a relationship, which is required, you'll select properly. If you don't know, whatever you know, that is you'll select. Then application performance will decrease. That will be happen. That's what this topic is most important. Okay, don't neglect. All required. Whatever I'm teaching, every point important only. There is no unnecessary point in my notes. The exact point, 1 line, 2 lines only I'm giving. That line is compulsory important only. Okay. See, I'm not giving paragraph style my notes, you observe. I'm not giving paragraph style. Exact point. That is enough. Okay. Now, here, one show method. System.out.println. Suppose A class. Here also one show method. Here also one show method, system.out.println B class. Now method name same, parameter list is same. This concept is called method name same, parameter list also same. Overloading or overriding? Overriding. Can we override methods in the same class? No. But in two different classes, you can. A class, B class. In between, you can write. Here show. Now what I'll do, here. Show methods are instance methods or class methods. Just I'm calling show. which show is going to be called? A class show or B class show? Which class? B class. So here implicitly what will be there? This dot show. Suppose myself I am writing this dot show. Then now A class or B class? Now also B class only. That is implicitly show this. It is explicitly this. That means both are same, no? So here what it prints? B class. Here what it prints? B class. In this case, super dot show. Then A class. Then A class. Okay. You observe demo class loaded, main method called, P object created, memory allocated for both A and B, that object referred by OB with that print method called. Then control comes here. Show. Then this B class show. So B class. This dot show. B class. Because here implicitly this, here explicitly this. Both are same. When super dot show, then A class. Println mistake happened. File save. Compilation, execution. See, B class, B class, A class. Okay. Write this one also. Example 2. In this situation, super keyword required because super class method, subclass method names are same. It is also this dot show. Implicitly this dot show. Not over. Here we return show only. It is implicitly this dot show. Implicitly this dot show. Okay. This dot show output B class. Explicitly this also same meaning. That's what B class only comes. So B class, A class. Whenever superclass member, subclass member names are same. If you want to access superclass member, then explicitly super keyword required. Okay. You studied this dot, this brackets, this arguments. You studied no? Now, this dot to access variables and methods. These brackets, constructors, default constructor, parameter constructor. This dot, will it come implicitly? Yes. Will it come implicitly in the instance method? Initialization block, constructor, class method? No. Static initialization block? No. This bracket semicolon, will it come implicitly? No. Will it come implicitly? No. Can we write second line? No. This dot can we write in second line? Yes. But these brackets you cannot write second line. These arguments you cannot write second line. That too you can write only in constructor. Okay. Now, this program successfully compiled, executed, output B class, A class. Same program, little bit I'll change. Okay. Now you observe. Just one keyword I'll attach here. What will happen? Give me answer. One keyword attached. What will be happen? Error? In which line error? Here error. Is it error? Line number 26, is it error? No. Okay. Next. 16, 17, 18. 3 errors. Only 16 error. 16, 17 error. 18, no error. 18 I didn't explain. Okay. Now you already studied. Static method does not refer this keyword in any way. Same style. Static method does not refer super keyword also anyway. Just note on 3 errors. 16, 17, 18. Note on. Static method does not refer this and super keywords in any way. Static method does not refer this and super keywords in any way. Static method does not refer this and super keywords in any way. So inside the static method, you cannot write this keyword. You cannot write super keyword. Implicitly not possible, explicitly not possible. Is it completed? No. One more example. What is this? What is? Constructor. Default constructor or parameter constructor? Default constructor. Now when consider is called? Whenever object is created. See, new A. New A. From here, control comes to A class default constructor. What is output? A class. Compilation, execution, output A class. Okay. Now here new B. New B. Okay. File save. What will happen? Just observe. Compilation, execution. What you are getting? How we are getting this one, I'll explain. You observe new B. From here, control comes to B class default constructor. But first, what is output coming? Here, implicitly super brackets will be there. Is one more concept implicitly. Many concepts are implicitly present. For you appears one type. For compiler appears one more type. What it appears to compiler, that is you have to assume. Then you will understand subject. So, here super, no need to write. Implicitly super present. What this super will do is, it calls super class default constructor here. Then A class. After that B class. So like that working. Now here new B. From here, control comes to B class default constructor only. But in that constructor first line, implicitly super bracket semicolon. What that line will do is, it calls super class default constructor. Then A class printed. After that B class printed. That's what you are getting, A class, B class. Explicitly, if you write super bracket semicolon, nothing will happen, no effect. See, now also same. If you remove that line, also same. If you add that line, also same. Now, before going to write that program, first you write these notes. Super brackets semicolon. Super brackets semicolon. It calls default constructor of superclass. It calls default constructor of superclass. It is implicitly present as a first statement in every constructor. It calls default constructor of superclass. It calls default constructor of superclass. It is implicitly present as a first statement in every constructor. It is implicitly present as a first statement in every constructor. It calls default constructor of superclass. What it will do is, it calls default constructor of superclass. It is implicitly present as a first statement in every constructor. Now, you observe. It will not come implicitly. It comes implicitly. Super dot will not come. Super brackets implicitly. This dot implicitly. These brackets will not come implicitly. Okay. Now, here, you observe new demo. From here, control comes here. Okay. Sorry. New B. New B, control comes to B class default constructor. Now, it is implicitly present as a first statement in every constructor. Here, implicitly present. Then it comes to A class default constructor. But I given notes implicitly present in every constructor. I said no. Here also super will be there. Here also super is there. Whatever I given notes, that is 100% right. Don't change. Okay. Here also present. But your doubt is there is no super class. Here one more concept is there. Here implicitly one predefined class, object class implicitly present. extends object implicitly present. That line in further sessions we'll study. That super also is there. So actually, welcome program only inheritance is there. It doesn't appears to you. Welcome program only inheritance is there. You'll write class demo, public static void main. Implicitly class demo extends object. Every class derived from object class. It is one class. Though this class you'll study later. This super keyword you'll study later. Present this one you should understand. That is later I'll explain. Okay. Here also super implicitly present. It doesn't appears. But your doubt is where is super class? There also one super class implicitly present. That class is object class. Object is one class. Class name is object. Class name is object. That class is available in Java library. Okay. Present that this super you learn. That super later we'll see. Here. If you write new B, it comes here. First line implicitly super bracket semicolon. It calls default constructor of super class. Then output A class. After that output B class. Like that comes. File save. Write example. Write example. Online students, end of the session and clarify your doubts. Listen the class and write the notes. Listen the class and write the notes. End of the session and clarify your doubts. Here, implicitly super. Super bracket semicolon. Implicitly present. It calls default constructor of superclass. Is it over? Say new B. From here, control comes to B class default constructor. Super bracket semicolon. It comes to default constructor of superclass. Okay. Say new B. Control comes here. Implicitly super. Control comes here. Then output A class. After that B class. It is one example. Here many examples required to understand this concept. That is, we'll see tomorrow. Tomorrow we'll see continuation. Today evening 7:30 p.m. HTML, CSS, JavaScript new batch is there. Those who didn't attend till those people you can attend. Okay. Online students, 1 minute, one by one, I'll clarify your doubts. Ayush, super keyword used to access instance variable of superclass, not for creating. Monica, still 45 days required, core Java. Lakshmi, HTML, CSS, JavaScript, 740, 745, I'll start. So you can attend, not a problem. Sai Teja, minimum 44 days required till. Parameshwar, I opened. Palash, your Oracle batch up to 745 is there. Okay, just 740, I'll start. 5-10 minutes, that's it. Otherwise, I'll inform to faculty. Ayush, super keyword not used to create object of child class. No, super only, that is only not completed. Tomorrow I'll continue. Rahul, present whatever I'm teaching as it is you practice and do it assignment while conducting exam, right? With that only you'll get a skills. We'll see continuation tomorrow.